Ladies and gentlemen, I am going to do a really quick crash course of completing the squares right now. Why do we do it? How do we do it? All the bits and pieces. First I'm going to start with the goal. So the goal of completing the square. The goal of completing the square is to take any quadratic, convert any, capital letters, any, underline, any quadratic relation into what form?
We're not allowed to tell.
Into vertex form. Okay? Any quadratic relation can be converted into vertex form. Maybe your quadratic equation looks something like this. I don't know. And you want to make it look like this. Why would you want to do that? This is called vertex form. It's called vertex form because HK is the vertex. Okay? If you can convert into vertex form, you get the vertex. You do that by completing the square. What kinds of questions do you do that in? Any time that it says, what is the maximum volume of whatever, or what is the maximum revenue Joni can make selling CDs at this price, okay? Any question like that. What is the highest that the rocket goes, and when does it get there? That's a vertex. All of those are vertex. Maximum, minimum questions. What's the minimum volume that will fit in the box with this dimensions? Okay, it's all this. It's all vertex form. Finding the vertex where h is the x-coordinate and k is the y-coordinate of the vertex. This is when or where, it doesn't really matter, but this is the value of the max. Okay, this is the value of the max or the min, and this is, I would typically actually say this is where it happens. Okay, so what I'm going to do is I'm going to take a whole bunch of quadratic equations and I'm going to break them into pieces, and I'm just going to do the steps, step by step, in order to help us get into vertex form by completing the square, okay? The first thing I'm going to do is show you how to make a perfect square. Now, there are full lessons on this in your videos. This comes from lesson 5.2 and 6.1, okay? The steps that you need. So here's a few problems. I'm just going to write them all down. I'm going to go x squared plus 6x. I'm going to go 2x squared plus 8x. I'm going to go x squared minus 10x, 3x squared plus 24x, x squared plus 5x, 4x squared plus x. Okay, there's a whole bunch of quadratics, and I'm just going to make perfect squares. Now, to make a perfect square trinomial, basically what that means is I can make a trinomial that can be represented as a binomial squared. So the goal is to go from a trinomial, okay, 3 terms, ax squared plus bx plus c, and it's going to be equal to a binomial squared. Okay, this is called a perfect square trinomial if it is. Not every polynomial is a perfect square trinomial, but we need to learn how to make perfect square trinomials if we're going to complete the square. So here we go. Very simple. All I have to do, identify a as 1, so it's not going to matter too much. B is 6, and I am going to add a constant that will make this a perfect square trinomial. In order to do that, all I have to do is take half of b and square it. So 6 divided by 2, that's half of b, which is 3, and square it. I need to add 3 squared. Okay? Or I could write it like that. This is now a perfect square trinomial. And this we could represent as a binomial squared in order to get this thing in vertex form. Okay, I'm not going to do all the steps. Right now we're just making that perfect square. B is negative 10. Half of b is negative 5. Negative 5 squared is positive 25. Notice they're always going to be a positive number because they're always a squared number. If half of b is a positive number, then a positive times a positive is a positive. If half of b, like in this case, is a negative number, then a negative number times a negative number is also a positive number. Here we go. B is positive 5. I need to take half of 5 and square it. Half of 5 is 2.5, or 5 over 2, and square it. Done. These ones are a little bit trickier. They have 2 steps involved because the coefficient in front of the x squared term is not 1, it's 2. So what I actually need to do when I'm looking at a and b is I'm going to group my terms with an x in it. In this case, those are the only 2 terms that I have. And I'm going to first factor out the 2 from both of the terms. Now, be careful, I did not factor out the greatest common factor. Then I would have been able to take out a factor of x as well. But in order to complete the square, I want a perfect square trinomial, which means I need an x squared term, I need an x term, and I need a constant. So what would I need to add to this bracket in order to complete the square? Well, I would take half of 4 and square it. So the perfect square trinomial in this case is going to be x squared plus 4x plus 4. But notice, and I didn't do this in the other ones because we were just doing that step of completing the square, but I've actually significantly changed the value of this thing. I'm just tacking on a plus 4 here. Well, in the next steps, we're going to learn that we actually need to subtract 4 as well. And because those numbers are all attached to a multiplier of 2, I actually have negative 8 on the outside. If you didn't catch that, that's okay. We'll do it again in the later steps. Same situation here. I've got to factor out the 3 first so that I have a 1 in front of my x squared term. That leaves me with x squared minus 8x. And now to complete this trinomial so that it is a perfect square trinomial, I'm just going to re-record those first 2 terms with the x, and my third term is going to be half of b squared. Half of b is negative 4. Negative 4 squared is positive 16. I also need to subtract 16 within the brackets, and then to kick it out of the brackets, because I don't need it, because I have a perfect square trinomial here, but I don't want to change the value of my expression. I need to subtract 16 within the brackets, multiply it by 3 to get it out of the brackets, leaving me with negative 48 over here. Now this piece in our next steps can be converted into that binomial squared. I'm just going to take this guy down here because I'm running out of space. This one's trickier. Again, you have to factor out the 4, but then you're looking at this and saying, no way, that's tough to factor out a 4. Well, it doesn't really matter if it's tough. You still have to do it. And this coefficient is 1. 1 divided by 4 is 1/4. So now I have x squared plus 1/4 x that I'm working with inside the group in order to create my perfect square trinomial. Same step. I need to take half of b and square it. Well, half of b is 1/8. I'm going to write 1/8 squared. Okay? And then I would also have minus 1/8 squared out here. 1/8 squared is 1/64, top times top, bottom times bottom, or top squared, bottom squared. So 1 over 64. So I'm actually going to subtract 1 over 64 within my brackets, but then I realize that actually has a value of 4 times itself, so I'm left with negative 4 over 64, which reduces to negative 1 over 16. Okay, so we figured out how to make a perfect square trinomial. I'm just going to rephrase now. Our goal in this whole thing is to go from something in standard form to vertex form. Okay, in this step, we're going to be converting a perfect square trinomial into a binomial squared. So we're focusing on this part right here. Okay, and here's how we do that. We have already created a perfect square trinomial. I'm going to write one so that we can talk about it. But this is just one that we've created up above in the previous step. And here is what that pattern is. We've got a squared plus 2ab plus b squared. Now, if it's in this pattern, I know it's a perfect square trinomial. This is how I built it in the previous step by taking half of this coefficient and squaring it. But this pattern helps us to see how we can convert it into the binomial squared. So I actually am just going to be taking the square root of my first term, putting it there, and the square root of my last term, putting it there. Done. Bracket, bracket, squared. Okay? And what you need to remember is that all of the information contained here is the exact same value as all of the information contained here. If you were to expand this out and simplify and group like terms, you would end up with this. Okay? Now let's just show it real quick. If I take a plus b, square it, that means multiply it by itself again. Look at what the expansion is going to get me. A times a squared. Outside times outside, a times b. Inside times inside, b times a. Last times last, b times b squared. Those guys are both the same. So I have two of those. A squared plus 2ab plus b squared. And isn't that what we have right here? Okay? So let's use this to convert our perfect square trinomials into squared binomials. It's really simple. I can use an equal sign now because they're equivalent statements. I've got my bracket. I don't want to forget that it's going to be squared. I'm going to take the square root of my first term, square root of x squared. What number times itself is x squared, Mr. B? X. X times x is x squared. So x. It's always going to be. Okay, and the square root of my last term, 9 squared is 3. Done. This is exactly the same as this. It's now a binomial squared instead of a square 1, 2, 3 trinomial. Okay? I'm going to write down my other problems so that we can rip through them real quick. Okay, my next perfect square trinomial is x squared minus 10x plus 25. I notice it's slightly different because my middle term here is a negative term, so I'm using this pattern here, which leaves me with a binomial squared that has a difference, a negative sign in between a and b. So here we go. Take the square root of my first term, x. Take the square root of my second term, but I know that it's a negative sign in between, and square it. Done. Over here, you notice I didn't square this. I left it as the fraction squared. I did that because I'm going to need the square root of it in my next step. So whenever you're dealing with fractions, it's often easier just to leave it as the square root half of b squared rather than actually squaring it out. If I squared this out, it'd be 25 over 4, which gets a little awkward to work with. And then I would have to take the square root of that to put into my binomial squared anyway. So if I just take away that squared sign, that's the same as square rooting it. And I remember that I now have a binomial squared. So that one's done. Here I leave my 2 on the outside as a multiplier. X plus square root of the first term, square root of the last term. X plus 2. And don't forget your little squared. This guy, leave the 3 out. X plus 4 squared, right? Square root of this. Or you could think of it as half of this. And my last one, again, it's a fraction, a big ugly fraction, so I left it 1 over 64 squared. And that becomes 1x plus 1 over 64, close bracket, squared. There you have it, going from a perfect square trinomial to a binomial squared. Okay, this time we're going to build on what we just did. This time, we're going to take those exact same polynomials, similar anyways, and we're going to make a perfect square. We're going to make a perfect square when c does not equal half of b squared. So there's going to be a constant at the end of each of these polynomials, but it's not going to be the one that makes it a perfect square. All right, here we go. Now I know that for this to be a perfect square, this number would have to be 9. It's not 9, okay? So here's what we need to do, and this time I can use equal signs because I'm not going to cheat. So here's what we do. We group these guys, our x terms, and we leave him out, okay? And we create our own perfect square trinomial with this information just on the outside for now. So inside here, I know that in order for it to be a perfect square trinomial, I need to take this 6, which is b, I need to cut it in half and square it. Okay? So it becomes 3 squared, half of b squared. But if I add 3 squared, I also need to subtract 3 squared. Notice that I didn't write this. This would mean you're squaring the negative sign, which would actually make this a positive number. which would be plus 9 plus 9. Well, I can't add 9 and add 9. That's just adding 18. That would change everything. Okay? I need to take away 9 because I've added 9. I don't want to change the value of it at all. And this negative 7 is still just hanging out there. Now, I don't need this for my perfect square trinomial. I have my perfect square trinomial right here. So my next step, I'm going to leave that in brackets, you'll see why in a second, is to kick him out of my trinomial. Okay? All it is minus 9. There's nothing else happening to it. There's no constant to multiply by. So I just have negative 9 outside with the negative 7. I'm going to do 2 steps in one here. I'm going to convert this perfect square into a squared binomial, or a binomial squared. Okay? Now what I need to know is this is a squared plus 2ab plus b squared. If you need help on that, that's lesson 5.2. Okay? But what that tells me is that I can very easily go into a binomial squared. Look where this 3 came from. It was half of 6. Yeah? It's the number that we squared to get our constant. Why does this make sense? Well, because if I squared this out, don't write this, but I would have x plus 3, x plus 3. I would end up with x times x is x squared. I would end up with x times 3 and 3 times x, which is 6 x's. And I would end up with 3 times 3, which is 3 squared. Okay? All the information here is also contained here. They have the exact same value, no matter what x is. Whether x is 1 or 2 or 0 or a billion, they have the exact same value. Okay? What happens outside? Well, negative 9 minus 7 is negative 16. Okay? I'm going to do the next ones a bit quicker, even though they're also challenging. I've got x squared minus 10x plus 1. All right, here we go. Group our x terms. Rewrite them. Take half of b and square it. Subtract it, because you can't just add 25, and you still have plus 1 on the outside. Now notice this time I wrote it as the square, not as the number squared. You could do it either way, okay? You can write 5 squared and 5 squared. Your choice. This is helpful because now you know that when you convert it into a binomial squared, that it's going to be x minus 5. Okay? This is actually supposed to be minus 5. Okay? Because it's negative 10. So that's one mistake. Okay. Carrying on.
Oh, yes,
here we go. This is, now I'm going to take this. This is minus 25, right? Negative 5 squared is negative 5 to the negative 5 is 25. It's minus 25. I'm going to take this minus 25, kick it out of the brackets, and I'm going to complete the square here. So we've got, well, the square is completed. I'm going to convert into a binomial squared. This is going to be x minus 5 squared minus 25 plus 1, x minus 5 squared minus 24. Why is this helpful? Well, it's in vertex form. Now I know that the vertex is at positive 5, negative 24. That means the maximum, the minimum happens at negative 24, and it happens when x is at a value of 5. So if you wanted to find out what dimensions of the box give it wouldn't make sense because it's a negative problem, but gives the volume, you would know that the minimum happens at negative 24, and it happens when the one length is 5. Again, yep, V is always vertex, capital V.
What about volume?
Yeah, so, okay, you're right.
Tuesday.
V could be different things.
He's on a road.
All right, here we go. This one looks a little bit tougher because I have a fraction out here. If I were going to complete this square, which I'm going to do, I'm going to group my x squared terms. I'm going to complete the square by taking half of b and squaring it. I'm going to add half of b is right there, and square it. If I add that, I also have to subtract that. And outside, I've kicked out my 7 over 2. By the way, 7 over 2 is just 3.5. 5 over 2 is just 2.5. Okay? They're just numbers. I leave them in fractions because it's easier for me to think about. Here we go. I'm going to kick this guy out of the bracket. So I've got x squared plus 5x plus 5 over 2 squared minus 5 over 2 minus 7, 5 over 2 squared, minus 7 over 2. Binomial squared, x plus 5 over 2 squared. Okay? X, 5 over 2. It's the exact same as we did in all the other problems. Here we go. This one's a little bit trickier. It's got a couple of steps here. 5 over 2 squared. You square the top and square the bottom. So that's 25 over 4. If I'm adding and subtracting fractions, I want to express this as a fraction over 4 so that I can subtract it. It's going to be 14 over 4. And then I can reduce in my last step. 5 over 2 squared. I have negative 439 over 4. Okay, what does that tell me? That tells me that the vertex is at x is negative 2.5 and y is negative 39 over 4. Okay, almost negative 10, negative 9.75. Right? Good. Let's get a bit harder here. 2x squared plus 8x plus 100. Why is this one harder? Well, we have a coefficient a that's not 1. But I do the same steps. I group my x terms. This time there's another step. I need to factor out that 2 from both of these terms. Okay? Now I'm going to complete the square inside, which is taking half of b and squaring it. I'm going to add that and subtract that.
I get this.
Now I need to be a little bit careful, because as I'm completing my perfect square trinomial, I don't need this negative 4, but I can't just throw negative 4 out of the brackets because he actually has a value of negative 4 times 2, which is negative 8. Okay? Here I can complete my binomial squared, x plus 2 squared, plus 92. The vertex is at negative 292. Okay, 2 more examples I'm going to do real fast. Again, first step, group your x terms and factor out a. Kick the last guy out. You're going to make your own square trinomial. You don't need his help. So here we go. Rewrite my x terms. Half of b, square it. If I add 16 in the brackets, I have to subtract 16 in the brackets. I don't need him, though, for my perfect square trinomial, so I want to get him out of the brackets, but I have to remember he's actually worth not negative 16. He's being multiplied by 3. So here we go. X squared plus 8x plus 16. Multiply him by 3 to get him out. That's negative 48 minus 6. Now I can complete. The square is already complete, so I can convert to a binomial squared. In order to do that, I take the square root of this and the square root of this. On the outside, we've got negative 48 and negative 6. That's negative 54. Done. Vertex for this guy, negative 4, negative 54. Stretch factor of 3. This guy's tall and skinny. Okay? Here we go. This is the hardest one on the page. Okay. Group your x terms. Factor out the 4. It's going to leave us with a quarter of an x. Leave the 2 on the outside. Now in order to create my own perfect square, I need to take half of b, which is 1 over 8, and square it. And if I add that, I need to be fair and subtract that, still within the brackets, plus 2 on the outside. I'm going to do one more step here to give myself something easier to look at. I'm going to leave this term, 1 over 8 squared, because it's going to help me when I write my binomial squared. But this term I'm going to actually expand. 1/8 squared is 1 over 8 times 1 over 8 is 1 over 64. Now I don't need that 1 over 64 for my perfect square trinomial. So I'm going to remove it from the brackets. Here's my perfect square trinomial. By multiplying by 4, I'm going to end up with negative 4 over 64, which is 1 over 16. Okay, so I've got negative 1/16 out here, and I'm going to add this 2. I'm going to express that as a factor over 16, fraction over 16, which is 32/16. And now I can wrap this thing up. I've got x plus 1 over 8 squared. That's my binomial squared. All of the information here is also contained here. They have the exact same value. And now I have plus 31/16. Okay? That square is complete, and it's now in vertex form, so you know where the vertex is.
I need a passing grade.
Quick edit, I forgot the square here. It's a binomial squared.
Sorry, I wasn't even trying